Absolute and percentage error. So we're talking about guessing things. We're being slightly inaccurate when we're rounding. So you might recall from yesterday's lesson we were rounding. What are you doing when you round? You're making an approximate answer. You're not getting the exact answer, so you have some inaccuracy there. It's important to acknowledge inaccuracy, which is called error. Now, the basic size of the error we call the absolute error. It's how much you are out by. Formally, the absolute error is written like this. The absolute error is equal to these vertical lines. These vertical lines enclose VA, take away VE. What does VA stand for? VA is the approximate value. It's your guess. Whereas VE is the exact value. What do those vertical lines mean? They're called modulus lines, but you're not doing methods, so it really doesn't matter. All you need to know in general maths is when you see the vertical lines, they just mean that if there's a negative answer there, you ignore it. It's always going to be positive within those two lines there. So, I'm going to give you a couple of moments. Can you get what absolute error is? It's equal to VA, the approximate, minus VE, within lines that make you ignore any negative sign. Writing time, please. All right, it's important to consider the idea of absolute error because it's not that useful sometimes. Sometimes it's not that useful because it depends on the size of numbers that you're guessing. So this in black, this is just for us to think about. You don't need to copy it. Consider if you had an error of 15 centimeters. You were wrong by 15 centimeters, right? So keep that in mind. You made a guess. Your mistake was out by 15 centimeters. What kind of how big is that error if the actual measurement you're trying to guess is 30 centimeters? If you're out by 15 centimeters for something that's only 30 centimeters, were you wrong by a lot? Was that a big error? Yes or no? This is how long it's supposed to be. And my guess was half of that. So in the context of the ruler, do you agree that that's a pretty big mistake?
Yes.
Good. This is a large error if the actual measurement is 30. But let's say your mistake was still 15. But if the measurement was meant to be 300 centimeters, is that still a large error? Huh? No?
Yes.
My guess, I'm supposed to be guessing something that's like this long. If I hurt myself, you can laugh, that's fine. This is 3 meters. And my mistake was 15. How much of this is 15? Only like a hand's width. Is that still a big error? No, it's small compared to what I'm measuring. So hopefully you can see that absolute error. So that is a small error if the actual measurement is meant to be 300 centimeters. Hopefully that demonstration shows you sometimes the absolute error is not that valuable because it depends on what you're measuring. So this leads into the idea of percentage error. Everyone gets what percent means. Because if I had a 2% error, is that tiny? Does it even matter what I'm measuring? If I know that I had a 2% error, it's only a little bit. If my error was 50%, what does that mean? I'm half out. Sorry, I just spat in your face. I'm half out. That's a big error. I don't even know what I'm measuring. So that's an example here. Consider if you were told a guess had a percentage error of 2%. Would that be a big error or small error? I was 2% wrong. Is that small?
Yeah.
That's a small mistake. But if I had a 50% error, would that still be a small error? Or would that be a big one? That'd be a big one. Notice that we don't... Have I told you what I'm measuring here? Before I told you the measurement was 30 or 300. I haven't told you what I'm measuring here. You don't even know. But you know that 2% is barely anything. And you know that 50% is a lot. See how that works? So, can I have everyone stand up, please? Can you sit down if I had you last year? All right, people standing up. Mr. T's class, on average, guessed his age to be...
35?
About 32.
36.
No cheating.
What do you guess? 37. He's gonna say it's like 25.
32.
Shh. How many people was that? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. 38.63. Mr. T's class on average guess his age should be 38.6. Mr. T is actually 39. Sit down. All right, A. Find the absolute error. Absolute error equals vertical line. VA stands for the approximate. What was this class's guess? Which number is the guess? 38.6. Minus my actual 39. That's not going to be a nice number. Who cares? You've got a calculator. 38.6 minus 39. Your absolute error was negative 0.4. And can you recall what did those vertical lines mean that I do with the negative?
Ignore all negatives.
Ignore it. So you're just saying you were wrong by 0.4 years.
That's pretty good.
Yeah, it's pretty good. That's the best I've seen. But it was that kid over there. That's fine. I'm not sensitive about that. Shh. Every birthday is just 1 year closer to death. It doesn't matter.
Real.
So get that, please. And then I need to give you a formula here. So this should have been in blue. The percentage error equals absolute error over exact times by 100%. Can you please get that formula down? I should have put it in a rectangle. So yeah, because we did it live, I can't control what your answer was. Do you agree that your absolute error was pretty small? You're quite close to the real thing. So also, because your absolute error was quite small, how's that gonna make your percentage error? Is that gonna be even smaller? You were pretty right before. So how do we do the percentage error? Well, your absolute error was 0.4 divided by, what was the exact amount? How old am I supposed to be? 39. You find the answer to that and you times it by 100%, which means you just put a percent sign there. So you go 0.4 divided by 39, times that by 100. You are only out by 1.03%, so 2 decimal points. That's good. I'll stop the recording there.